Okay, so in the last class we discussed uh, properties of transition elements along with electronic configuration, and also we discussed that transition elements are going to form complex compounds. Okay, or obviously we are going to discuss D subshell. D subshell. D subshell basically it was not the part of AS. के मतलब कि हम बताते थे but we were not used to, like you can say, draw the structure of the subshell, but अब हम उसको draw करेंगे. Okay, अच्छा. So D subshell has total 5 orbitals. Okay, D subshell has total 5 orbitals: dxy, dyz, dzx, dx square y square, and dz square. So total 5 orbitals we have for the D subshell. For the D subshell, बिल्कुल ऐसा ही है. Like it's just like a P subshell. It's just like a P subshell. So P subshell
स्क्रीन
had
शेयर नहीं हो रही है इसकी.
three three orbitals, है ना फैसल? Three orbitals, 1 2 3, px, py,
सर
pz.
स्क्रीन शेयर नहीं हो रही है आपकी.
स्क्रीन शेयर बेटा मेरे पास तो हो रही है, आप चेक करें जरा. जुमर, डू यू हैव माय स्क्रीन? हेलो.
जी
ओके फैसल चेक करो यार. ओके, dxy, dyz and dzx, then dx square y square and then dz square. Okay, so there are 5 orbitals of D
हो गई है.
subshell. तो उनके नाम you need to memorize. Okay, what are the names of the D orbitals? So there are total 5 d orbitals. Okay, now they are dxy. If you can see this, this is dxy. Okay, and this is dzx, and this is dyz, and this is the dx square y square, and this is the you can say dz square. Okay, this is dz square. Basically, what are orbitals? Orbitals are the area in which the probability of finding an electron is maximum. That's the d orbital. That's it. कि basically हम उस जगह को फोकस कर रहे हैं कि where is the electron around the nucleus, and what is the fashion of electron, that how it revolves around the nucleus. Or obviously that area is called orbital. That area is called orbital. Remember. Okay, let me show you the animation of the orbital. Now you can see this. Okay. Yes. So as you can see this, hmm, this is dx square y square. It's on the axis, and then we have x और y के between बन रहा है ना ये. So x और y के between बन रहा है ना. So that's why this is called xy. xy. And then this is the orbital which is in between, which is on the axis. This is on the axis. It's not between, it's on the axis, it's not between. Okay, so this is called x square z square. And this is in between, like it's also called dzx or dxz. It's between the two orbitals. तो इस तरह से orbitals होते हैं d orbitals. Some are between the axes and some y square dz square. Okay, so different mods basically आपको बता रहा है कि it's just like that. It's just like that. Okay, when they combine together, so they are going to form this. So collectively, there are five orbitals: dxy, dzx, dyz, dx square y square, and dz square. So collectively, this is just like that. तो ये होते हैं orbitals. So you need to draw these orbitals, and you need to know that how many orbitals I have. We cannot draw this on the notebook because this is a complex. How can you draw this? How can you draw this? So individually, the examiner would be asking to draw dxy, to draw dyz, to draw dzx, to draw dx square y square, and to draw dz square. तो individually वो आपसे पूछ रहा होगा. So you must know this, okay? And then after this, I told you in the last class that how the complex compounds are going to be formed. Complex means what? Complex means that when metal makes a bond with a non-metal. In this case, this is called the ligand. This is called the ligand. Okay? लेकिन ये होता कैसे है? So basically, metal has a positive charge generally. Generally, this is a general statement. Okay, metals form cations. Metal forms cation. Okay, metal forms cation. So cation means that they need electron. Cations means that they need electron, right? So ligands have extra electron because I told you the definition of ligand, that ligands are electron donor. Ligands are electron donors. ये बात हम कर चुके हैं last class में कि ligands are electron donors basically. So when the ligand donates electron to this metal, so obviously they would form a complex. They would form a complex, which is in which you can see the arrow. In which you can see the arrow. Arrow means that they are going to form dative bond. Arrow means that they are going to form dative bond. Remember, arrow means that they are going to form dative bond. Remember. So dative bond is when the lone pair, when the electron pair is shared between the two atoms. So this is your electron pair, which is being shared between this metal and this ligand. So they are going to form a complex compound. तो अब इसकी practical example where this complex is. So I would say that if you have copper sulfate, so if you remember in AS or in IGCSE, we used to tell you that copper sulfate is of blue color. Aqueous, hydrated. There are two types of copper sulfate. Number one, we have hydrated copper sulfate. Number two, we have uh, anhydrous copper sulfate. Anhydrous copper sulfate is white. Anhydrous copper sulfate is white. Remember, anhydrous copper sulfate is white, but hydrated copper sulfate is blue. Why this is blue? Obviously, copper is a transition metal, and we would be explaining the color of the complexes. But right now, I want to tell you, okay, how the complex is going to form between copper sulfate and the water. If you can see this, copper sulfate contains copper 2 plus ion, which is of blue color, which is of blue color. कॉपर सल्फेट में कॉपर 2 प्लस होता है, जिसकी वजह से ये जो कंपाउंड है आपका, ये ब्लू है. Now what happens, if you can see this, when you are going to dissolve this copper into the water, so obviously water has a positive and negative charges. Okay, water is polar. I can say that water is polar. Polar means charge. Water is polar, and polar means charge. So water has lone pairs as well. If you remember the dot and cross diagram for water, oxygen has two lone pairs. If you remember, this is water. It has two lone pair. It has two lone pair. Okay. So when water is going to make a bond with this copper metal, so so they are going to form dative bond, dative bond, dative bond, dative bond, dative bond. So this is a complex in which the water is a ligand. The water is a ligand. For your simplicity, ligand is equal to the nucleophile. If you remember in AS, you used to discuss nucleophile, nucleus loving, है ना? याद आ रहा है ना आपको? न्यूक्लियस न्यूक्लियोफाइल हम डिस्कस करते थे जिस पर नेगेटिव चार्ज होता है। क्यों नेगेटिव चार्ज होता है? ड्यू टू इलेक्ट्रॉन्स। क्यों नेगेटिव चार्ज होता है? ड्यू टू इलेक्ट्रॉन्स। सो ligands are the same. So ligands are the same. Ligands are the same. Remember, okay? Ligands are the same. So ligands, which means that they have a lone pair of electron. So they are going to make a bond with a metal. In this case, the metal is copper. So when water is going to make with this copper metal, so I can also write this copper H2O6, and the charge of copper is +2. Since there is no charge on water, it's zero charge. So ultimately, I would be writing the overall charge on this complex. So now always the between the metal and a ligand. It can be any metal, it can be any ligand. It can be any metal, it can be any ligand. ओके कुछ भी हो सकता है, कुछ भी हो सकता है। याद रखिएगा ये बात। ओके सो अच्छा, हाउ द कॉम्प्लेक्स लुक्स लाइक, दिस इज वेरी इंपॉर्टेंट क्वेश्चन। हाउ द कॉम्प्लेक्स लुक्स लाइक, so you would always see this bracket, you would always see the metal, you would always see the ligand, you would always see the number. This is called the coordination number. This is called the coordination number, and this is the overall charge on the complex. Overall charge on the complex. Overall charge on the complex. You will always see. तो इस तरह से आपको कोई भी कॉम्प्लेक्स नजर आएगा, लाजमी 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 110%। ओके okay, then what is coordination number? What is coordination number? Coordination number means the number of dative bonds which is formed between the metal and a ligand. The number of dative bonds between the metal and a ligand. This is called coordination number. This is called coordination number. Sometime coordination number is 2, sometime 4, sometime 6. Okay, it depends. Okay, who is the ligand? Whether the ligand is going to make double bond, like the 2 bonds, 4 bonds, 6 bonds, how much bonds it's going to form. तो फिर वो हम case to case vary करेगा ये। तो before going into detail, I want to tell you regarding each and everything so that आने वाली चीजें आपके लिए थोड़ी सी आसान हो जाए। कुछ terms हैं that you need to know, that what is coordination number. I told you. Now, what is a ligand? Obviously, I told you it's an electron pair donor. What is the charge on ligand? What is the charge on ligand? Ligands can be negative and they can be neutral. They cannot be positive. They cannot be positive. Remember, ligands, ligands cannot be positive. Ligands cannot be positive. Remember, ligands cannot be positive. क्यों? When something is positive, it means that they have no electron. And if they have no electrons, so how they can donate their electrons to someone else? बात समझ आ रही है? If they have no electrons, so how can they donate their electrons to someone else? So obviously they cannot act as a ligand. So for a ligand, one thing is very important, that is they must have electrons. Okay, let's suppose we have water. You all know that water has no charge. It's H2O. Water is H2O. There is no charge on water, but on oxygen atom we have two lone pairs. अगर आपको याद हो, when we used to draw the dot and cross diagram for water, so we have learned that on oxygen we have two lone pairs of electrons. Okay, So it can act as a ligand because it has an electron. It can make a bond. It can make a bond. Okay. It can act as a lone. It can act as a ligand because it has electron. Okay. So then after this we have ammonia. Ammonia. Ammonia is NH3. There is no charge on ammonia. Okay. There is no charge on ammonia. Okay, there is no charge on ammonia, but ammonia can act as a ligand. If you ask why, so I would say that in ammonia, the nitrogen has one lone pair. So it has a lone pair of electrons, so it can act as a ligand. Okay, and also the carbon monoxide, it has no charge, it's neutral, but it can act as a ligand because it has oxygen. So oxygen has a lone pair of electron. तो याद रखिएगा कुछ लोग ये समझ रहे होते हैं कि मतलब इट्स मैंडेटरी टू हैव अ नेगेटिव साइन नो दिस इज मिसकॉन्सेप्ट इट्स नॉट मैंडेटरी टू हैव अ नेगेटिव साइन ligands can be neutral. The thing is that we have to identify the lone pair of electron. If they have lone pair of electron, yes, they can act as a ligand. It's very simple. It's very simple. Okay. Okay. Then ये है वो negative ligands. ये है वो लाइगेंड्स नेगेटिव 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 सो ये आपको याद रखना है पता है आपको ये आपको याद रखना है यू हैव टू मेमोराइज इट you have to memorize the list of negative ligands what is the charge on the ligand if the ligand is -1 if the ligand is -2 okay तो ये आपको पता होना चाहिए अच्छा then there are of ligand on the basis of charge neutral and negative ligand. Apart from this, you must know, you must know the types of ligand on the basis of the sharing of lone pair. Some ligands can share one lone pair. Some ligands can share two lone pairs. Some ligands can share three lone pairs. Some ligands can share more than three lone pairs. Okay. So you must know this. You must know this. Let's suppose this is monodentate ligand. Monodentate means that mono means one and dentate means teeth. Teeth means electron pair. तो कुछ लाइगेंड्स ऐसे होते हैं जो अपना एक लोन पेयर डोनेट कर सकते हैं दे आर कॉल्ड मोनोडेंटेट लाइगेंड द लाइगेंड व्हिच कैन डोनेट ओनली वन लोन पेयर ऑफ इलेक्ट्रॉन उनकी एग्जांपल क्या है जो मोनोडेंटेट है Cl minus Br minus OH minus ammonia H2O NH2 minus NO3 minus etc तो ये वो ligands हैं who are going to donate only one lone pair. Who are going to donate only one lone pair. Okay, then we have a bidentate ligand which can share two lone pairs. जैसे कि En एक ligand है. I would be sharing the structure. En एक ligand है and also the C2O for 2 minus is called oxalate ion. Oxalate ion. It can also act as a ligand. It's a bidentate ligand. It can donate two lone pairs. Then we have polydentate ligand. Then we have polydentate. Poly means many. Many bole to more than two. Many bole to more than two. So which can donate more than two lone pairs. The very famous ligand is EDTA. EDTA. It has 6 lone pairs. It has 6 lone pairs. Okay. You need to memorize it. Okay. Now, if you can see, I'm asking the coordination number in this complex. Obviously, the coordination number is 6 because there are 6 water molecules that are going to make a bond with copper. So they are going to make 6 dative bonds. When they are going to make 6 dative bonds, so what's the definition of coordination number? Obviously, the number of dative bonds. And by what's the definition of coordination number? Obviously, the number of dative bonds between the metal and the water and the ligand. Okay. 6 coordination number है इसका. What about this? Acha, this is very important to know. Okay, En is a ligand. So what is the nature of this ligand? Is this monodentate or a bidentate or a polydentate. So we have learned previously that En is a bidentate ligand. So there are three En. There are three ligands. Each ligand can donate two electron. Each ligand can make two dative bonds. Okay. Each ligand can make two dative bonds. So three ligands कितने bond बनाएंगे? Six dative bonds. Each ligand can make two dative bonds. So three ligands कितने बनाएंगे? Six bonds. तो आपने six लिख दिया यहाँ पर. कंफ्यूजन ये होती है कि सर यहाँ पे तो थ्री लिखा था, आपने सिक्स क्यों लिखा? बिकॉज आई नो द नेचर ऑफ दिस ligand, which is a bidentate ligand. I know the nature of this ligand, which is a bidentate ligand. Okay, so that's why I have written six over here. ये हो रहा है? Okay. One bidentate ligand makes two dative bonds. So three bidentate ligands make six dative bonds. Okay. Now you can see this in this question. This is from the past paper. They have asked to identify the coordination number and calculate the oxidation number. Obviously, in this complex, there are two different ligands. This is also the monodentate. This is also the monodentate. Two monodentates, two monodentates. So there are four dative bonds that are going to be formed between the metal and the ligand. So that's why the coordination number is 4. And in this, there are two ligands, 4 water and 2 Cl. And obviously, after the memorization, you would be able to identify that water is a monodentate, and also the Cl is a monodentate ligand. So there are 6 dative bonds that are going to be formed between the metal and a ligand. Okay. And now, what is the charge of a metal in this complex? What is the charge of a metal on this complex? चार्ज को कैलकुलेट करने से पहले आपको लाइगेंड का चार्ज जरूर पता होना चाहिए. कैसे? अब लेट्स सपोज this is nickel that is to be calculated, and I know the Cn is -1. Each Cn is -1. क्योंकि I told you in the list of negative ligands, the example was cyanide, like Cn minus, and ammonia, it was a neutral ligand, means this is 0. So -2 and 0, it's equal to 0. So nickel is equal to +2. This is the charge of nickel in this complex. Okay, in this way you can calculate the charge of nickel. And in this complex you can calculate the charge of chromium, that is a metal. So obviously Cl is -1. Obviously the Cl is -1. Okay, because this is a negative ligand and this is water. Water is neutral, that's why I took 0 over here. And then I have calculated, after the calculation I got chromium is +3. So इस तरह से you are going to calculate the charge of a given metal in a complex. Okay, ये समझ आ रहा है दोनों को? Yes or no? आसान है? Okay, आगे चलूं? Yes, Zumar. फैसल.
Yes.
फैसल ओके है? फैसल चलो आगे चलते हैं. Now see this. They are asking to identify the ligand. So it can act as a ligand because it has a negative charge. It can act because fluorine has a lone pair of electron. It can act because ammonia के जो nitrogen है, like amine के उस पे lone pair of electron है. So it can act as a ligand. ये positive है. It cannot act as a ligand. This is the positive one. It cannot act as a ligand. Okay. तो पॉजिटिव आ गया ना. मैंने आपको ऑलरेडी बता दिया कि पॉजिटिव वाला कभी भी लाइगेंड नहीं हो सकता है, बिकॉज इट हैज नो इलेक्ट्रॉन. और जब तक इलेक्ट्रॉन नहीं होंगे तो वो कंडीशन को कैसे फुलफिल करेगा, बात समझ रहे हो? तो ये है। अच्छा, दिस क्वेश्चन एक समराइज्ड क्वेश्चन है ये, कि इसको करने के बाद काफी चीजें जो है ना समराइज हो जाएंगी, कि कोऑर्डिनेशन नंबर किस तरह से बताना होता है, अगर आपको चार्ज दिया हुआ हो तो फॉर्मूला कैसे लिखना होता है, तो ये सारी चीजें हैं। ओके, सो लेट्स सपोज जरा आप कैलकुलेट कीजिएगा बेटा इसे दोबारा से, जल्दी से, शाबाश, फटाफट, जल्दी से इसको फिल कीजिएगा बेटा, शाबाश, फटाफट। यस, अच्छा चलो, आई एम गोइंग टू टेल यू, ओके, द फर्स्ट वन फॉर यू, since the charge is negative 3, since the charge is negative 3 and the chromium is your metal, so I'm writing chromium and then the cyanide, that is a ligand. Okay. Acha, overall charge they have given, that is -3. How much ligand I'm supposed to have to get -3? Since I know that cyanide is -1, -1, and chromium is +3. So obviously I'm supposed to write 6 over here so that it can become -6, and this is +3 would give you -3. Are you getting my point, Zumar? Yes or no? Zumar?
Yes.
यस,
Yes.
तो थोड़ा सा टेक्निकल क्वेश्चन है, थोड़ा सा टेक्निकल क्वेश्चन है ये। तो आपको ना ओवरऑल चार्ज भी दिया हुआ होगा, एंड यू आल्सो वुड बी गिवन अ मेटल, also the ligand, and then you are supposed to make your complex compound, and obviously the coordination number should be 6. As you know, there are 6 cyanide ions which are going to make a bond with the chromium metal, so that's why the coordination number is 6 with the charge of -3. So it's very easy, it's very easy. Okay, then uh, you have next nickel. Overall charge they have not given to you. Overall charge is not given. Overall charge is not given to you. Okay, but they have given you the coordination number. कोई मसला नहीं है, इसकी हेल्प से हम बना लेंगे फॉर्मूला, कोई मसला नहीं है। करूंगा कैसे, जरा देखिएगा। दिस इज निकल। अच्छा, इसको मैं शॉर्ट फॉर्म में लिख रहा हूँ, दिस ligand is called En as well. Okay, overall charge is 3 minus, and you know the charge is 2 plus. Okay, अच्छा अब, and they have given you the coordination number is 6. Obviously I need to write down 3 over here, 3 over here. Okay, 3 over here. अच्छा, ओवरऑल चार्ज तो इन्होंने नहीं दिया हुआ ना आपको, ओवरऑल चार्ज तो आपको दिया ही नहीं है इन्होंने, तो मैं इसको मिटा रहा हूँ यहाँ से, राइट? ओके, ओवरऑल चार्ज तो इन्होंने आपको दिया ही नहीं है। मैं दोबारा लिख रहा हूँ, सही है, मैं दोबारा लिख रहा हूँ। ये आ गया निकल, ये आ गया En 3। अब आप बोलोगे कि यहाँ तो 6 लिखा हुआ है, मैं 3 क्यों लिख रहा हूँ? क्योंकि आई नो En is a bidentate ligand, each En can make 2 dative bonds, so 3 En would make 6 dative bonds. Nickel is plus 2. This is a neutral ligand, so overall charge of the complex would be plus 2. It's very easy. So before going to write down the formula of the complex, you must know the nature of the ligand and also you can say the charge of a ligand, that whether it's -1 or -2 or yeah, मतलब ये सारी चीजें neutral है जो भी है. Okay. Uh, you can try E. Then I would tell you, you can try E fast. You can try E. Yes, क्या है formula जुमर?
पी टी ब्रैकेट में Cl और फिर उसके ऊपर 2+ का चार्ज.
इसके ऊपर 2+ का चार्ज. ओके. तो बेसिकली अगर हम इसकी बात करें तो दिस इज Pt, that is the platinum, and then obviously this is Cl. Overall charge is given to you, that is 2 minus. So how much chlorine I am supposed to have to make it 2 minus? Ultimately the platinum is 2 plus, so I would say 4. Minus 4 and plus 2 would give you -2. That's why the overall charge is -2 and the coordination number is 4. Zumar ऐसे किया था काम. Is that okay?
जी.
Good हो गया जी, good हो गया, great हो गया, great. Then we have iron. You can try iron as well. You can try iron as well. They have given you the formula as well, okay? You are only supposed to say these things. So, this is having the two negative charges, so means that this is a bidentate ligand, right? Bidentate means each ligand is going to make two dative bonds. If we have three ligands, if you can see this, three ligands, obviously they are going to make six dative bonds. They are going to make six dative bonds. Okay, so coordination number should be six. And since iron is 3 plus and each auxiliate is minus 2, so there are 3. So minus 6 and plus 3 would give you minus 3. So the overall charge should be minus 3. Okay. Are you getting me, Zumar? Yes.
Yes.
Okay, okay, okay. Okay, okay, okay. तो इस तरह से ये है कॉम्प्लेक्स की सारी चीजें और बातें. ओके, वी वुड बी डूइंग मोर पेपर्स इंशाल्लाह. वी वुड बी डूइंग मोर पेपर्स. बाकी इसके अलावा जो है, how can we calculate the charge, how can we identify the like you can say the coordination number. So again I'm telling you that you have to memorize the list of the ligands and the types of ligand, neutral, negative, each and everything you must know. Okay. Okay.